Hello, let's continue with a lecture. This time, another sort of business application, actually an economics application here of calculus and derivatives. And this time we'll be talking about elasticity of demand. For short, we can just call it elasticity. It's generally assumed that we're talking about demand. So this will go back to our ideas of supply and demand and things of that nature. And when we talk about this idea of elasticity, really what we're going to be saying is, all right, let's say that you have some good, whether that's gas or rice or car or just anything that you could purchase or buy. And let's say that the price of that good changes. Well, the question is, if the price of that changes, I want to know how that changes the demand for that product. So when that price changes, I want to know, does it drastically affect how many people want to buy it? Um, and I want to take a measure of how much does it affect how people want to buy it. For example, if I take a car, let's say you go out and you want to buy a brand new automobile for $20,000. Well, if I change that price to $20,001, that's not really going to change your likelihood to buy it. The difference in price there really just isn't that. It's not really that big, relatively speaking. You're only adding $1 to a $20,000 purchase, so you're not really going to change your likelihood of buying it. And that's kind of this idea of elasticity here. So it's a measure of how sensitive the demand is when you change the price of something. So how we measure this, there's sort of two ways that you can think about measuring this. There's an algebraic way, which is sort of the most that's sort of the baseline way, and then you can actually turn it into a second way, which is more calculus based. So let's go ahead and look at this. Let's say that I have a good and I'm going to shift the price. So like I said, I'm going to change the price from $20,000 to $20,001, or more realistically, maybe it's a gallon of milk, and we change the price from $3 to $4. So when that happens, and let's keep using this gallon of milk example, if I change the price of a gallon of milk from $3 to $4, presumably when you increase the price, less people are going to buy it. And so what we'd say here is that the quantity that's demanded is also going to shift. So when I increase that price of that gallon of milk, less people are going to buy it. If I were to decrease the price of that gallon of milk, maybe from $3 to $2, more people would buy it because it'd be cheaper, and they'd say, "Hey, milk is cheap. This is great. Let's go ahead and use it." Um, and so when we change the price, when we have a shift in the price, we're also going to have a shift in the quantity that is demanded, the quantity that consumers are saying, "Hey, we need this. We all want to buy it. We're demanding this. So make more," or something like that. And so this idea of elasticity, it's a ratio, and it's measuring the change in quantity divided by the change in price. So let's start with this change in price. Let's say I change the gallon of milk from $3 to $4. So that change in price would be indicated by that $1 change right there. Well, when I do that, the quantity that's demanded, the quantity that will eventually be sold, is going to change as well. And so that would be represented up here on that top, on that numerator. You'll notice there's a negative sign here. And so I actually want to explain that negative sign with an example. And I'm gonna make up some numbers here. I'm not gonna be too formal about this. Let's go ahead and copy this formula over just so we can see it while we're doing our example. So we've got this E right here. So let's go ahead and use an example. Let's say we're talking about this gallon of milk. And let's say that when the price equals $3, the grocery store that's selling this gallon of milk ends up, over the course of a day, maybe they sell 100 gallons. And then they're going to change this. Let's go ahead and change the colors here. So they're going to actually now change this to, okay, all right. So the grocery store says, we're going to increase the price to $4. Well, when that happens, you're probably not going to sell 100 gallons anymore. You're going to sell 75 gallons, maybe. And again, I'm making up numbers here, but that's okay. So when we actually calculate this elasticity here, we have this negative sign that I'll explain why we have that there in a second. And then let's look at the change in quantity. So we ended up at $75 and we started at 100. So I want to take the difference there. And then the price, we ended up at $4 and we started at $3. So what you'll notice here, again, this negative sign that I haven't explained yet, and on the numerator, we have negative 25. And on the denominator, we have a positive 1. And so what you're going to notice is that if I increase this price, the number that I sell is going to decrease. And that just makes sense. If all of a sudden I made a gallon of milk, if I changed it from $3 to $30, you're probably not going to sell very many gallons of milk there. And so as the price increases, the quantity decreases. And so this portion of this formula that I'm boxing right here is going to end up being negative because an increase in price is going to correspond to a decrease in quantity, or the opposite. If I were to decrease the price, I would have an increase in quantity. And so basically what we're seeing here is this change in quantity and the change in price, they're always going to be opposite of each other in terms of what sign they are. When one's positive, the other's negative. When one's negative, the other's positive. And so this negative here sort of helps us, this negative out front, I should specify, that sort of helps us make sure that we end up having just a nice positive number there. And here we just say the elasticity is 25. We would box that. That would be our answer. We haven't talked yet about what that exactly means, but that would be the case. That would be our value there. So that's kind of just an example to show why we have this negative sign out front. So let's go ahead and look at this a little bit more in depth. So I want to copy this formula down again. Let's actually get that. Let's make sure we copy that over. So when we look here, what you could actually recognize is that the change in the quantity over the change in the price, this is going to be a little bit hand wavy what I do here, but bear with me here. The change in quantity, we could represent that by delta Q, and that delta is just a sort of a variable, a symbol that I'm using to represent change. And we might say that delta Q is divided by a Q, because really what we'd be saying there is when we look at that, we're saying, all right, there's a change in the quantity, but we're going to look at that relative to what the original quantity actually was. Likewise, we're going to do the same thing with price. We'll have the change in price divided by the original price. And this down here kind of gives us a sense of, hey, how much does the price change relative to what the initial price was? If this, what I'm doing right here, doesn't make a whole lot of sense, that's okay. Really, I'm just using this to explain and have us see that algebraically, we're going to end up with P over Q multiplied by delta Q over delta P. And then there's a whole lot of other stuff you could do in terms of calculus. And really, you can turn this delta Q over delta P into a derivative. And we'll use that notation dq dp, recalling from our derivative notation rules that this is a derivative of the function Q with respect to the variable P. So we want to keep this in mind, that P here is a variable and Q is a function. And so we have a Q right there, but we want to remember that that is a function of P, of the price. So the quantity is a function of price. This is a whole lot here. I'm not really going to focus too much on this. If that's confusing, just look at this right here. We've got our definition of elasticity. This is a more calculus way of saying this. Because of the way that this looks, we have P divided by Q right here. I want to really make it clear that this dq dp, that is a derivative. It's not two things divided by each other. So DQ is not, something. DP is not something. It's DQ over DP. This is one entire entity here, and it is a derivative of Q with respect to the variable P. So let's go ahead and talk a little bit about actually what values we might get for elasticity and what they mean. So we did an example before where we got an elasticity of 25. We saw that here, and we didn't really talk much about what that means. Let's go ahead and do that now. So if you do your calculation, so if you take your formula here and you plug in your price, you plug in your quantity, you look at the change, you look at the derivative of Q and P, or maybe you choose to use this formula. You look at the negative change in quantity over the change in price, and you calculate it, and let's say you get something less than 1. That we call inelastic. So we'd say whatever good we're talking about, that good is inelastic. And what that means, when you get this E is less than 1, that means you're getting something like a fraction. You're getting something like 3 over 4 or 1 over 2 or 2/3 or something like that. Just anything that looks like that fraction where that denominator is larger than the numerator. That's what makes that value less than 1. And that's what I want to focus on. That denominator is less than the numerator. So if I look back here, excuse me, I misspoke there. I said the denominator is less than the numerator. I meant the denominator is larger than the numerator. That would give me a fraction. That would give me something less than 1. So what we're saying here, when a good is inelastic, that means E is less than 1. So let's go ahead and mark that there. E less than 1, inelastic. And there we go. So in this scenario, our denominator is larger than our numerator. So what this means is that if I change the price, the quantity is going to change less than however much I change the price by, because this denominator is larger. So this is bigger than that. So if I change the price by a certain amount, the quantity is going to change by less than however much that price changed. So if we sort of exaggerate this and take this to the extreme, I could have a really large change in price and it doesn't affect the quantity that people buy. If that happens, let's say our change in price was like 100 and our change in quantity, so you increase the price of this good by 100. Well, if the quantity only changes by 2, so 2 people, -2, so 2 less number are purchased, right? Maybe gallons of milk. If you change the price of a gallon of milk by $100 and only 2 less are sold, that's not a very big change, right? You're seeing 1 over 50 here if you simplify that. And so what we're saying here is when you end up with this E less than 1, which means inelastic, that's saying that a change in price does not really affect the change in quantity that much at all. You can change this thing by $100 and the amount different that is sold doesn't really change. And so an example of this, a couple examples of this, would be something like gasoline or rice or medical services even. So let's start off with gasoline as an example. Gasoline is a necessity in today's world. Almost everybody has a car, and in order to power that car, you need gasoline. And so really, if gasoline prices were to skyrocket, it really wouldn't change how much gasoline is purchased because it's just such a necessity in our daily lives. We really need it. If gasoline all of a sudden became, $7 a gallon, you might buy a little less of it, but you're still going to buy it because you have to get around in your car. You have to use your car as transportation. Obviously, at a certain point, maybe you change your mind, you start to ride your bike instead, maybe you take the bus and things like that. But to a point, it doesn't really change how much gasoline you'd buy. Medical services are a great example of this as well. If you have to rush to the emergency room, you're not at that point, you're maybe you're in the process of dying and maybe you need just emergency medical attention. You're not going to worry about how much it costs you. They could charge you $1, they could charge you 100, they could charge you $10,000, and it's not really going to change your likelihood of purchasing those medical services, because it's something that you drastically and direly need. So that's something that, if I change the price, if I increase the price of medical services, it's not really going to change how much people use them, because they have to use them, otherwise they might die, or they live with a broken arm or something like that. Rice is a great example of a food that is inelastic. And so rice, maybe a little bit less so in America, but in a lot of other countries, rice is kind of that staple food. It's that staple food group that sort of is the base of every meal. And so it's, rice is very filling, it's very calorie dense. And so, and well, also we know now that rice is pretty cheap. But here's the thing: if you actually increase the price of rice, it doesn't really affect the demand very much, because it's so calorie dense. It's such, a core food that people use and that people eat, that even if you increase the price of rice, people will still buy pretty much the same amount. You could buy a bag of rice for $1, they could change the price to $5, and it doesn't really change the amount that that is purchased. So these are examples of inelastic goods, goods that if you change the price of them, it doesn't really affect how much is purchased. What you'll probably notice here is you'll think, all right, well, if, based on what we're saying here, gasoline is inelastic. Why don't they just make gasoline $10 a gallon? Because they know people are still going to buy it. And so that's actually where the government can come into play. And actually, on a lot of inelastic goods, there are certain restrictions and certain laws put into place that restrict the price that they can be sold at. The price a lot of times is set by the government. So just exactly for that purpose, that the company or whoever is selling the gasoline or the medical services or staple groceries, staple foods, that the government will step into place and they'll actually mandate the prices that these things are sold at, so that those companies that are selling them can't just skyrocket the prices knowing that you'll still buy them. And so, yeah, inelastic goods right there. The opposite of an inelastic good would be a good that is elastic. And so let's say here that we're looking at some items like fast food or a car, or in general luxury items, maybe jewelry or things of that nature, or a television, a really expensive TV or something like that. When we do our calculation, we get E is greater than 1. What that means is that our numerator is larger than our denominator. So when I have a set change in my price here, I'm going to have a large change in my quantity. And what that's saying is that if the price changes, the quantity changes a lot. And that's an example of an elastic good. And we can look at some of these items here, like fast food. If you change, let's say you doubled the price of fast food. So maybe you go out and you get a burger at a fast food restaurant. A burger, fries, and a soda cost you $8. A fast food. Well, if all of a sudden you double that and that costs $16, you're pretty likely not to buy it nearly as often. And really, the general population will pretty much just stop buying fast food, because the point of fast food now is that it's pretty cheap. But if you all of a sudden make it really expensive, if you change that price a lot, it's really going to affect how many people buy it. A car is a great example. If you were to take the base price of your standard sedan, your standard new sedan, maybe around, $16,000, $17,000. If all of a sudden you made that $30,000 or $50,000, no one's going to buy the car anymore, because it's just too expensive and there are other alternatives. Same thing with like a lot of luxury items like jewelry. Something like jewelry is not necessarily something that you need to live. It's not a necessity in your life. And so if you make the price really expensive, if you change the price and you make it really pricey, you're just going to buy less of it, because it's not a necessity. And you contrast that with something like gasoline, where you could increase the price a lot of gasoline, but it's a necessity in your life, so you're still going to buy it. But on these elastic goods, if you change the price, it's going to affect the demand a lot. And you could even go the opposite way. Think of a car. If all of a sudden, your standard new sedan, cost you $8,000 instead of 16,000, they're going to sell a lot more of them because, all of a sudden they're pretty cheap. And so, the demand would increase with that decrease in price. So we've got these E less than or greater than 1 corresponding to inelastic and elastic. You might be looking at these and saying, well, what if E is exactly 1? Well, if E is exactly 1, we call it unit elastic. And that's just a term that we use here. And really, it's just saying, hey, if you change the price, it just kind of perfectly affects the quantity demanded. If the price increases, the demand will decrease in just a very sort of expectant amount, an amount that you could kind of expect. It's not drastic, if you will, in terms of how the demand is affected. So, all right, let's go ahead and get into an example here. So we did an example before where we looked at that non-calculus formula where we just wrote change in quantity divided by change in price. But here, we're now actually going to use our E is equal to negative P over Q times the derivative of Q with respect to P. And what we'll notice here, as I mentioned before, Q is a function and P is your variable. So keep that in mind. P is our price. It is our independent variable. It will vary and it will change, but the quantity is what is affected by that price change. So Q is a function of P. Sometimes you'll see this written as Q of P. I'll kind of squeeze that in there. I haven't written that here. That's fine. Some people write it, some people don't. So we've got Q as a function of P. So the very first thing that I should do here is I should go ahead and I should write out negative P. Remember, P is my variable, so I leave it there. Well, then Q is negative 3P plus 4. Q is a function of P. And so I should make sure to replace Q with what it is in terms of P. Then when I go to my derivative, I'm going to slightly change my notation here. ddP, so that's my derivative of, or with respect to P, of Q, which is negative 3P plus 4. Right there. And now we're done with our calculus pretty much. We're done with our business, I should say. We're done with all of that setup. We've looked at our formula here. We've plugged everything in. If we continue on, we have negative P over negative 3P plus 4. The derivative of this negative 3P plus 4 with respect to P is just going to be a nice simple negative 3. You'll notice these negatives cancel right there. So we can kind of mark that, cancel, cancel. And so we end up with 3P, let's put this in blue, 3P over negative 3P plus 4. I'll choose to write this more often than not. I'll choose to write it as 4 minus 3P. You don't have to. Either is perfectly acceptable, either of these last two. That's just how I'm choosing to write it right now. We got that right there. That is our formula for our elasticity. That's fantastic. We've got it. We may ask ourselves now, for what price points is this good elastic or inelastic? And let's just remind ourselves. So we have E, let's do a different color there. So E is equal to 3P over 4 minus 3P. And so when we want to look at inelastic, we're setting E less than 1. So let's actually do that. 3P over 4 minus 3P is less than 1. Well, then 3P is less than 4 minus 3P. That's just me multiplying 4 minus 3P on both sides. If I add 3P to both sides, I have that. And then if I divide by 6, 4 over 6 is 2/3. So when the price here is less than 2/3, which we haven't talked about units or anything, presumably this is in dollars, that's fine. But when our price here is less than 2/3, that means that E is less than 1. So this would tell us exactly where our price, or for what prices we are inelastic. I'll write INE. And then likewise, we could say, hey, elastic, E is going to be greater than 1. Well, it's basically the same exact work that we did here, just the sign of that inequality is flipped, and you get P, I'll label it P sub E for elastic, is greater than 2/3. And again, no units or anything like that for now, but yeah, that would tell us where our good is elastic versus inelastic right there. And so we found our price points. There we go. We have a formula for our elasticity, and that's really about it for elasticity. And that's pretty much all we're going to do here. So we'll go ahead and call that the lecture, and that'll be it.